Thank you very much for having me. Buenos dias. It's very pleasurable for me to be here in beautiful Ecuador today. So thank you for having me. So yes, I'll let's see the slides. There we go. So yes, as we said, I'll be talking about application-driven infrastructure today. So what I'm thinking about here is that when we use cloud, especially when we begin to use cloud, we often hope that it's going to give us a complete platform ready to use out of the box. In practice, what the cloud platforms give us is components. They give us materials. So if you look at things like the AWS service catalog, there are hundreds of services to select from. So really what they're giving us is something that we have to assemble our platform for ourselves. And so what often happens when we do this is we end up building something that is not quite what we had pictured in our mind when we started. So when we're building cloud infrastructure, especially when we're learning, when we're first adopting, the infrastructure tends to grow organically. We figure it out as we go along, and so it gets kind of messy. The architecture pattern is potentially described as a big ball of mud rather than something nicer. When we have this kind of an architecture, when we have this kind of infrastructure where we have infrastructure as code on a cloud platform, but in kind of a messy implementation, it can be very difficult to make changes to it and very risky to make changes, which means it's difficult to update, it's difficult to improve, it's difficult to kind of maintain high quality. And so what tends to happen in practice is that we're building a new legacy system rather than kind of leaving the legacy behind us, which is what we would hope to do when we're moving to cloud. So where we should be going and how we should be using cloud. We should be using infrastructure to deliver value to our organization. It should be very clear to us what exactly we're doing and how it provides and supports and enables value for the organization. We also need to build systems that evolve continuously. So you may be familiar with the book Evolutionary Architecture, which is written by several thought workers a few years ago, which talks about software systems and how to build them so that they can be changed easily and will be changed continuously. And this also applies to our infrastructure. Our infrastructure is something, whereas we might start out thinking we create an environment and then we're done and we don't need to make changes to it. In practice, we need to be able to make changes to our infrastructure. We need to be able to do updates and security patches, also updates to new versions and to add new capabilities. Otherwise, legacy accumulates and we end up having to kind of modernize a short way down the road again and again. And a key to doing this is to bring modern software engineering practices and principles to our infrastructure code. And this is something that I think as an industry, we haven't really been doing as well as we could, or we haven't reached the point of maturity, I think, that we could. There are many lessons that have been learned in the field of software engineering and software design that we haven't really worked out how to do well with infrastructure code. So how can we do this? I'm going to talk about defining a modern infrastructure platform strategy. In other words, what are the elements of planning and carrying out the building of a platform for managing your infrastructure on the cloud that takes advantage of modern ways of thinking about software design, software engineering, software delivery. So I'll go through 5 points. Don't need to worry too much about what all 5 of these are right now. I'll go through each of these in a little bit more detail in a moment. But before I do that, I want to answer a question which I'm often asked, which is, do we really need a platform if we're using cloud? Doesn't cloud give us the platform already and we can just set that up and then build applications right onto it? So we want to think that it's like this, that we build our applications on top of the cloud infrastructure and we don't have to do too much in the middle. We don't need to invest too much because cloud is providing that for us. Well, as I mentioned earlier, what cloud tends to provide for us is primitive resources, services that we have to put together. There was an article written by Corey Quinn a little while back, which I have a link to here, which is called, he talks about on AWS, there are 17 different ways that you can run a container, from things like EKS and ECS and these to various other ways that you could run a container. And this is what creates mess in our infrastructures, because all of these kind of choices compile or combine to kind of create quite a messy system. So platform services is thinking about, in our organization, in our team, in our teams, how do we run containers on AWS? Which of those 17 ways is best for us, or do we use in different situations? And that's just one example. Obviously, there are many other things that we need to include in our platform. So this middle layer of things that, even though we're using cloud, we have to think about this and plan this so that it doesn't evolve in this kind of very messy, unplanned way. And we can think about how these platform services work as kind of like a developer enablement for applications. So if you think about developers working on products, working on applications and services, how are they going to use the infrastructure? How will they access it at what level? And it may be things, sometimes things like developer portals and those kind of things can help as a part of this, in providing that interface to development teams. And then beneath this, and what I'm going to be talking a little bit more mostly about, is this kind of idea of how do you build those platform services from the infrastructure. So I'm calling this infrastructure orchestration. And this is where infrastructure as code comes in. You use these tools to put together services for developers, but what are good ways to do that in a well-structured way with those modern software engineering practices? So this is about how do we, in our organization and our team, integrate and consume infrastructure as code. And when I say we, I mean we as in you, your organization, your team, whoever we are working with infrastructure. How do we do these things? So now I'll get to these kind of 5 points, elements of a strategy for a modern infrastructure platform. So the first one is application-driven platform architecture, which is obviously the main theme of this talk, and it's where we kind of start from. So if we go back to this kind of stack that I showed a little bit earlier, where we have applications sitting on top of platform services, which are built from infrastructure primitives from the cloud, we're starting with that application layer. And we start out by thinking about who are the stakeholders in building and running applications. And so these stakeholders are many. It includes the obvious ones like development teams, testers, and other people involved, support teams, anybody involved in building and delivering and running the applications on the platform. These are all stakeholders that we need to think about. This is really about taking the same approach that we would take for any kind of product thinking for our platforms. It's thinking about identifying those potential stakeholders, maybe thinking about things like user personas for them. Maybe you have in your organization, if you have a large organization, you might have some teams which are doing things in different ways from other teams. And so you need to think about how to build and provide services to them in different ways. So having things like user personas for those development teams and testers and other stakeholders can help to articulate that. And you can think about what are the organizational priorities. So if you think about your organization as a whole, what is it that they're trying to do or need to be able to do with the infrastructure? So it might be things like being able to get new products and features to market quickly. It might be things like expanding into new regions or with new partners, say, or it might be integrating new businesses, that we acquire a company and need to integrate their systems into ours. There's all these are just some examples of the kinds of things that our organization might, at a very high level, care about, that we have to be considering when we're thinking about the best way to design our infrastructure. And then you can also get into things like, what are the cross-functional requirements and operational requirements in terms of things like capacity, in terms of availability in different parts of the world, security, and all these kinds of things. All of these have an implication even for business folks and so on who may not be thinking too much in technical terms, but we need to be thinking about the implications for them and how to have conversations with them about their priorities so that we can feed those into decisions about how we're building our platforms. So as I mentioned, using ideas from product thinking and thinking about our application teams and other people who are working on using our platforms, We can also use things like domain-driven design. So obviously we start using, if you're familiar with domain-driven design, it's a way of thinking about the systems that you're building, applications and products, what they're composed of in terms of the capabilities that they need to have and how they interact and how the domains align with them. And so we start by doing that with our applications, but then we need to think about how to bring that down into the platform and the infrastructure. So you might have domain concerns like it could be things like logging and availability, traffic management. It's all these kind of things that the infrastructure handles. It's very useful to think about these things in those terms of domain, rather than thinking about them in the traditional ways, which tend to be very much about the functional, and especially in technology. So in many organizations, clients that I've worked with, you find that you have like a Linux team, an Oracle team, teams that are organized around technologies. So rather than thinking about things that way, it's useful to think about it in terms of what services are being provided and thinking about what are the right ways to kind of group and align those boundaries in terms of the architecture of the system, including the infrastructure, but also that can have implications for your teams. If you're familiar with the inverse Conway maneuver, which we talk about in the ThoughtWorks technology radar, it's this idea of making sure that we have our team structures are reflecting what we need our technology architecture to be, because they will inevitably have a mapping and come out that way. So then another thing we can do from that, so once we have thought about these domains, we can build what we call a technology capability map. And so that's thinking about, for a given application, or maybe a type of application, what are the kind of services that it needs? So over on the right here, I've listed, we worked with was working with a client in Turkey, a bank in Turkey last year, the year before. And they were looking to re-platform from mainframes into a modern cloud type of a platform. And so we looked at their estate of applications and we grouped them. They're the new generation, things being developed as new applications and products where they were using more modern technology like containers and serverless. And then we also could group some that were in what we call the last generation, which was J2EE, things running on application servers, and they were using Oracle database for those. And then we had the legacy generation, which was services that were the core banking things that were still running on the mainframe. And so that helped to group, because it was a very large portfolio of applications and software. That helped us to kind of group it and to talk about, okay, for the new generation, for the last generation, for the legacy, what services do we need to be able to provide to them? Do we need to provide messaging services? Do we need to provide certain types of database services and so on? And so building out the map that way so that we can identify for a given application, what is the subset of platform services that we need to be able to have, to support those applications. So that leads us on to the next step, which is thinking about a way to do an incremental roadmap for building out and evolving our platform. I think one pitfall that people often fall into when thinking about a platform is they try to design the whole platform and they try to build the entire platform, a fully fledged platform, before making it available and moving applications onto it. And that obviously can take a very long time. It always takes longer than you think, costs more than you think. It also delays the feedback that you get. You finish building the platform, you put applications onto it, and you find, oh, we made some decisions that actually maybe weren't correct because we didn't know until we started running applications on it that some of the things we needed were actually different. So a good way to think about a roadmap, again, this is for infrastructure, right? Is we start with business outcomes and think about what those can be, what's relevant for the organization, and then think about what do we need to do underneath to enable those outcomes, which is kind of built from that capability map that we made earlier. So we might have a first milestone where the business outcome is the business wants to see a proof of concept, and they want to be able to deliver new applications more quickly than they could before. So we have a kind of a measurement we can put on there about how quickly we can get new applications into production and new features into production. And so in terms of the capabilities to provide that, we want to be able to continuously deliver and update the new generation of applications. And so we maybe put things in place like pipelines and basic deployment. And we do this maybe for a subset of applications and application capabilities. So maybe at this point, we can put applications into production, but simple applications. Not every application is ready to use the platform at this point. And by kind of explaining in the roadmap in these terms of, well, what is ready to go onto the platform at this time and what is not ready, it helps to set those expectations with stakeholders and with people in the business who are prioritizing and deciding on investment, so that they don't expect too much and expect the platform is ready for anything. And so then the second milestone might be a pilot, where now we can provide some more key business critical functionality than we could before, and we can do it more effectively. So where you can define more effectively, and this is an example, right? So in one organization, it might be that we can now deliver this functionality across multiple regions very easily and update, when we update our functionality and make fixes or new features to it, we can roll that out across regions very easily. So then that kind of, again, helps us to decide which parts of our platform, which services do we need to implement, and how do we need to implement them in order to meet this milestone. And so then we can move on to saying we want to have a very large public launch. We can provide higher operational quality, and that might be things like capacity, for example, to say, we can have very large scale number of users and transactions and business activity happening on the platform at this stage. So then that helps us to decide, because maybe in those earlier milestones, we didn't need to provide maximum capacity. Maybe we just need a limited capacity for the particular things that we were delivering at that point, but now we need to increase that. And then finally, we might have business as usual. So we're now able to run, and we're able to kind of run things more cost effectively and manage our costs in relationship to revenues. So things like auto scaling and other things, where as business increases, we can provide more resources very quickly to meet those demands. And then if demand falls from the business, then we can reduce and lower costs to match that. So these are just some examples, right? In every organization will have different kind of priorities in terms of outcomes that they want to deliver and what order they want to deliver them. But this kind of model of thinking about those outcomes and then thinking about what technical functionality and infrastructure we need to make available to meet those helps us to deliver incrementally, so that we can do something simple quickly, get some value from it, get some learning from it. And so those roadmaps then help us to identify incremental slices of work. So again, going back to that diagram of applications on top, platform services, and so on, where we made a capability map, we can say for this first level, we don't need to build the entire platform that we have in our mind for later. We can just build some of the things that we need in that platform. So this leads us to the next concept, which is kind of an evolutionary platform service development model. So what I mean by this is each of those kind of services, let's say like a monitoring service or a container hosting service or a database service that we're providing to application and product teams in the cloud, how can we evolve that? So this is a model that came from some work we did with a couple of clients in Australia, where the challenge is often when we say we're going to build a capability, let's say a container cluster, we're going to build a container Kubernetes cluster that application teams can use. Well, oftentimes when we say we're going to build something and have that first release, stakeholders will think, okay, everything can now move on to that. Everything is ready to go. And so what was useful was to think about, well, how can we define different levels of availability so we can, again, manage the expectations of what is it possible to do when, at what point, and what do we need to invest to kind of move things on to the next level. So for example, at an experimental phase, if we're building a new service, let's say there's a new database tool that we need for machine learning for our data scientists. And so we can say the first iteration of this is something that we can use in production, but for non-business critical uses in data, we're going to have a simple version of it. And maybe we have things, we define things like only one team is able to use it at this point. So it's not ready for everybody in the organization, just this one team we're working with to make sure it works well for them, and we're learning how to implement it well. And then at the next level, we go to alpha and we say, okay, we can add some more teams onto using this machine learning service, and we can have a certain number of users, but it's not going to be massive scale, and maybe it doesn't automatically recover. So we're kind of defining for each of these levels different kind of very clear criteria of what we expect for that service to kind of move to the next level. And this also then feeds back into that roadmap and feeds into backlogs of work because we say, in order to take this machine learning service from experiment to alpha to beta and so on, we have a set of stories, or maybe probably at this level epics we've defined. And this is the work we will have to do in order to achieve that. And so that helps to make decisions of priorities of, do we need to take it to that next level? Maybe for something like machine learning, it doesn't need to reach that general availability where, 20 or 30 different teams are going to use it. Maybe it's only going to be 2 or 3 specialist teams using it. So it doesn't need to have all of the requirements of a general available service. And then this also feeds into patterns for the teams that provide these services. So I should have provided a link, but there's a book, Team Topologies, which gives some very good ways of thinking about how to structure teams and how teams interact with one another. So what we're basically saying is that we can have, in some cases, we have teams that are working in a more collaborative model. They're helping each other more closely, as opposed to then the teams that provide something as a service, where you can just use what that team provides. So if you have a team providing a machine learning service, the team that uses that doesn't need to go and ask them or raise tickets. They can just, there's an API or there's something on a developer portal that they can use. And then facilitating is a model that can be useful for a service that maybe doesn't have to be self-service and quite as mature as the others. Maybe if there's only one team that needs to use a particular service, a platform team or some other kind of infrastructure team or some team like that can help that team to build the service they need without necessarily trying to make it into something that is packaged in a way for everybody to use. And so this maps along with that evolution of the services, or it can map along. You can think about when you're first building a service, it often works best rather than having a separate team building a service and then coming back and saying, here, my service is ready for you to use. They say, we're going to work together. And often this is done as a part of the team. So a development team or a product team might themselves build the service in the first instance at that kind of experimental alpha stage where they're the only ones who are using it. And then over time, as the kind of demand is seen that, okay, more other teams might need to use this as well, we can say, okay, what do we need to do in order to take it to the next level, to make it more reusable and shareable and so on. And so the team shape that we have for that might be different. We might decide now is the time to set up a separate team that is going to manage this apart from the original product team that built it and used it. And I think this is a really important thing of the idea of bringing platform services out of teams who use them, as opposed to having completely separate teams building them from scratch in isolation, so that you make sure that you're building something that really does have value to its users and you understand that very well. And then, you can have different kind of team, again, topologies, depending on how the service is provided. So then this gets to the collaborative platform ownership model. So this is, how do we structure teams that own platform services and build them and use them and so on? So typically, especially in larger organizations, and especially in organizations that grow organically with different maybe products or divisions being set up, or even companies being acquired or merged and so on, is that you get a lot of kind of overlap of different services that do the same kind of thing. So we worked with a client in California last year, where we found that they had, I think, 4 or 5 different teams building Kubernetes clusters. And so that can be okay. So one of the kind of pitfalls of this is the messiness is that you can get inconsistency and overlap. Sometimes it is okay. It's not that you need to make one team building the Kubernetes cluster that everybody uses, because there might be different use cases. So maybe a product team that's doing high scale needs something different from a team that's using it to do machine learning and processing lots of data. Maybe those clusters need to be set up in different ways and designed in separate ways, that it makes sense to have 2 different ones and even 2 different teams building those. But it needs to be deliberate, as opposed to something that just happens just because. Having this kind of messiness, especially when there's dependencies and integrations between teams, can make things, again, going back to changes, become very slow and risky and disruptive. If you change one service that is multiple teams use, you might break something. And so you become very reluctant to make changes, and you end up putting on lots of process around changes, which makes it very difficult, which means you move slowly. And again, you accumulate legacy because you're not able to kind of keep upgrading and updating your systems as technology changes. can also give a lack of visibility and control of costs. On cloud, this becomes very important because it's very easy to run up large bills. So having many different teams doing different things in different ways makes it difficult to kind of manage that and keep an eye on it and optimize for costs. And then also operational quality might be inconsistent. So stability, performance, security. Some teams might do those things very well. Some might do them less well. When everybody's kind of doing their own thing, it becomes difficult to kind of keep that together. So what people often turn to is to say, well, let's make a centralized team that owns everything. And so you're not allowed to make a Kubernetes platform for yourself. We have one team that makes everything and owns everything, and you have to get it from them. In practice, especially for larger organizations, this tends not to scale or work very well necessarily. So one thing that happens is the central teams might not build the service in a way that meets the needs of all of its users. So they might make it in a way that helps some users with their use case, but then often what happens is you have other teams that have needs that the implementation doesn't meet. And because often then the team becomes a bottleneck, this platform team becomes a bottleneck, or maybe it just becomes difficult for them to service the needs of all the teams. And so it may just not help. And so then because of those kind of delays and changes and improvements and adding features that people need, what often happens then is you get a lack of adoption. So working with one client in the UK, but they had a platform team that decided we're going to mandate to the rest of the organization, you must use our platform, you can't use something else. And then what happened was we had there was another group within the organization which was doing something very high profile. So this was government related. So the things they were working on were, there were stories in the newspaper about how long this was going to take to build and so on. And so that team said, the platform team isn't building things that we need quickly enough in the way that we need. So we're going to do our own thing. And they were able to get approval from the top to say, yes, you are not required to use what that team makes. And this happens all the time. And maybe somebody gets approval because they're high profile like that, or maybe they just go and do it and don't ask. And so by trying to force everybody into using the same platform, often it doesn't work. And the reality ends up very much like that original picture where you have a mess of things, maybe even more than one platform team trying to be the team that tells everybody how to do things. So an alternative to this is what we can call a collaborative platform architecture. And so this is the idea that you're going to have different teams building different services, using different services, sharing different services. So rather than trying to dictate from the top who does what and how it's done and what gets built, you focus on how these things, these different teams integrate. What are the boundaries between them? So this is where we go back to that domain-driven design, where if we create a common language for the kind of capabilities that might be provided by a platform, that then helps you kind of talk about, okay, who's doing what, how are they doing it, what are the boundaries between them and so on, and how are they aligned to business goals. So again, going back to what I said earlier about we've defined outcomes in ways that make sense to the business in terms of what their goals are, we can use those when we talk about the different capabilities that different teams might be wanting to provide. And the boundaries, it's important to have those kind of boundaries. So who owns what and how do we collaborate between those teams? And then define standards for integration and sharing across those boundaries. So this is very much like the way the internet was developed. The internet was developed by defining standards for how does an email client talk to an email server, rather than saying this is how you build, one team is going to build a client, one team is going to build a server that everybody in the world must use. The standards body said this is how they talk to each other, and anybody can build a client, anybody can build a server as long as they follow these rules. And so that can be a very helpful thing within an organization to think about, to focus on how can different teams each have the freedom to build what they need, but still integrate with the rest of the organization. And so this gets to the final point of the platform strategy I'm talking about, which is composable infrastructure implementation. So this is going back down to that bottom level there and saying, so again, we've got these kind of layers of application and platform and infrastructure. Platform enables development teams. But when I get to that kind of bottom thing of that infrastructure orchestration there. And so a good way of thinking about a unit of architecture for infrastructure is something that we can call an infrastructure stack. So this might be a Terraform project with a state file. might be a cloud formation stack, Pulumi stack, what have you. But the idea is that this is a independently deployable unit of code. So to be clear, this isn't the same as perhaps if you've worked with infrastructure code and you know there are things like modules and so on, which help you to kind of modularize and share and reuse code. Those can be useful for organizing code, but they are not separately deployable. It's kind of like a library and an application. You can have a monolithic application which uses libraries, code that's in shared libraries, but the application as a whole is monolithic, can be very slow to deploy, difficult to manage, and hard to make changes to. So infrastructure is the same way. We want to break down our infrastructure into independent units, using infrastructure as code to build things, and then we combine those together to provide a service. So if a service is like, say, a machine learning service, it might have stacks which provide like a data store, some compute resources, and some other types of things in different infrastructure projects that we then instantiate, integrate together in order to provide that service. And so the thing that we're thinking about at the kind of strategic level is, well, so how should teams build, package, and deliver those infrastructure stacks? And so this is where we have things like maybe we agree on technical principles, and we look at principles like design principles like solid, that we can borrow from object-oriented design, or kind of more modern rethinkings of that, like the Cupid. If you're not familiar with that, it's worth having a Google of Dan North, who's a former thought worker, define this kind of way of thinking about design principles called Cupid. And so having these kind of things, deciding as an organization, what are the principles we should use? So for example, we can say that one infrastructure project doesn't know the details of how another infrastructure project is implemented. And this is Demeter's law from object-oriented software design, because that helps to keep things loosely coupled. If you have an infrastructure project which maybe uses a networking constructs created by another infrastructure project, that makes them tightly coupled and difficult to change without breaking things. So having these rules and having these kind of common standards and conventions for how you build something that another team might use, or how you use something that another team has built, can be very helpful. And then also maybe thinking about things like, how do we package and deliver these stacks? So for delivery, for instance, I think taking again from software engineering and say that continuous delivery and pipelines are actually a concept we should be using for our infrastructure code. So rather than having a separate copy of infrastructure code for each environment, we should try to use the same code, have it parameterized so that we can reuse that code across environments and ensure that we have consistency across them, and ensure that we're testing our infrastructure code before we're putting it into production. So that's a very quick kind of summary of these kind of 5 areas that build on one another, starting with the applications and thinking about the purpose and the value that our infrastructure is delivering. So again, it comes from bringing modern software engineering into our infrastructure code, things that we've learned in object-oriented and other kinds of fields of software engineering for 20, 30 or more years. How do we apply these and learn lessons from that for our infrastructure code? And then that is something that we can use to build systems that continuously evolve. So if we build well-designed, loosely coupled infrastructure systems, we can improve them continuously, update them continuously, and avoid accumulating legacy technical debt and those kinds of things. And then again, that comes up to being able to use our infrastructure to focus on delivering value. Thanks. I don't know if we have time for Q&A.